I'd have to say the quality of the images I'm working with is hopefully lower than yours. I'm finding that a lot of these images, they didn't really take a particularly good set of pictures. I've got good information from one bank, kind of minimal information from the other, and they clearly didn't walk up and down the channel. So we'll work with what we have. But the first thing I'm going to do is, well, what I'm going to suggest you do is, as you're working through your images, once you've worked through your images and have found all the flags and labeled all the flags that you're able to find, the next step is to go to Workflow, first save your job. Definitely save your job. So File, Save it to the same folder that you're putting your pictures in. And then go to Workflow and align your photos again. I'm going to repeat that step. Once Agisoft is done, I'm going to look over in Workspace, clicking down here at the lower left-hand side, and I see this R next to my map, which is great news. That means that Agisoft, even though it doesn't have a particularly good fix on things, here's my point cloud, and it doesn't have a lot of information. I had kind of a bad set of images. Yours are going to no doubt be better. If I click on the icon that looks like a camera, I can see where those images are taken from. And they're pretty well organized. So even though they're minimal, I don't have a lot of them, I've got enough. Looks like this person kind of walked down the stream and took a few pictures, but I don't have very many from the bank. That would be really great. If they had walked up and down the bank, in addition to walking the channel, we'd have a lot more to go on. And they only walked the channel a little bit in this direction. They did a better job walking back this way. But we'll work with what we've got. The R means that this is referenced. So just by walking through my images and marking the locations where the flags are, where the stakes are, I was able to give it enough information that Agisoft is ready to generate a dense point cloud. The way I know that is I see this R under Workspace. If I don't see that, I need to take further steps, and I'll talk about those steps in a little bit. But if you see an R, that means you can click Dense Point Cloud. I'm going to make this an aggressive dense point cloud. It takes a lot longer like this, a high quality, aggressively generated dense point cloud. I'm doing this because I don't care how long it takes. I can walk away from it while it's processing. You may want to set the settings differently depending on how many pictures you have. I think this will probably take about 15 to 20 minutes. Once the dense cloud is made, you can look for it by clicking on the Model tab. And you'll see there are several icons here. I'm going to recenter the model after I've been spinning it around. I'm going to turn off these cameras. And then I'm going to click this Dense Cloud. So you can see I've got a much more lifelike depiction of the stream. Even with that fairly lame set of pictures, we're able to capture an enormous amount of detail here. You can see it's kind of filling in the gaps in places. And you can see that this really is a set of three-dimensional points that it's modeling. So it's basically extracted information from those images. Think of images as being two-dimensional points, and it's sort of pushing and pulling these around relative to each other to turn it into a set of three-dimensional cubes, basically. Now the next thing I'm going to do is I'm going to take that dense cloud and turn it into a mesh, meaning I'm going to turn it into a three-dimensional surface. Rather than points, it's going to be polygons, triangles, connecting those points. I'm just going to use the default settings here. This will take a minute. When the mesh is done, it's kind of hard to tell. But up here at the top, if you click on this triangular icon, you'll see that you can generate a solid model or a wireframe model, about the same thing. But these are both generated from that mesh. And you can kind of see, if you zoom into a spot, that what you've actually generated is a triangulated irregular network, sort of based on the locations of the points the program thinks are defining the surface. Pretty cool, pretty detailed, and yeah, just sort of impressive to noodle around with once you see it. The next step, though, is because this mesh is just kind of generically colored, we're going to do one more step and build a textured model. And I'm just going to accept the defaults here, and again, this will take a minute. Now once that textured model is built, you can check it out by clicking on the triangle icon again and going to Model Textured, and what you'll see is a really lifelike depiction of that model that you've generated. Really stunning. Even with, like I said, fairly modest quality photographs. You can see we only got one bank. We don't have a lot of the bottom of the stream. So your pictures will no doubt allow you to build an even more brilliant model than this one. But just by identifying the stakes that were visible in the picture, this is what we got. Now there are two more steps. What you're going to eventually work with in ARC is a digital elevation model, or DEM. So we're just going to accept the default settings here, and I want to point out one thing, and that is we're creating a raster of elevation with a resolution of 0.002 meters, so 2/1000ths of a meter, so teeny tiny. Compare that to the DEM I gave you, the DEM 2015, created from LiDAR data. I believe its resolution is like 2.7 feet, so this is much, much higher resolution. Defaults, let that get built. And once that DEM, digital elevation model, is complete, there's not a whole lot to see here. You're almost done in Agisoft. As you can see now, it doesn't take that long. And the last step is going to be exporting this DEM into a format that we can open it up in ArcGIS. Before we do that, I just want to say a couple things. One component of your lab submission, one thing that you will hand in with your deliverable, is several different views of your objects that you've created in Agisoft. There's really no right or wrong way to put these together. I'm just looking for you to noodle around with your results a little bit and find the ones that you think are most showy. That's pretty good. And insert a couple screenshots into your work. And if you're not sure about how to do that on the lab computers, the tool I use is Snip. If you search for snipping tool, it looks like this once you turn it on, and it just allows you to take a screenshot of whatever you want to capture, and then seems to have disappeared on me, and then export the result, save the result as an image file. I usually save it as a PNG. If you have any questions about that process, just let us know. But the idea is to get a few different versions of your point cloud or wireframe or textured model, whatever you think shows off your results the best, into your deliverable report. The other thing you're going to do is take the result of this and imagine our point locations for the buckets, for the stakes themselves in this reach, are about here where my cursor is, and about here. And when you were there at the creek, this group would have stretched a string across the stream. Now what we're doing in the deliverable is we are creating three different renderings of that cross section. One that sort of mirrors using the process using Google Sheets, mirrors the process you use to measure with the string down to the water surface and down to the bed of the stream. I then also give you, and it's in a folder called Elevation in the Lab3 data file, a DEM, digital elevation model produced by the federal government, which shows elevation throughout the region. You have to download these one small tile at a time, so it's a good chunk of campus. And we're going to imagine putting that DEM right on top of this and doing exactly what we did with the string. Imagine taking a line across this grid showing us elevation and just teasing out the elevations of each square. We're going to do the same thing with a grid we make from our 3D model. And so that's what we just built. That DEM step was building an actual two-dimension rendering, a really fine-grained rendering of what this model tells us. And before we're done, we need to take one more step, which is opening up that, exporting that DEM so that we can use it in ARC. So I just go to File, Export, and I say Save DEM. I've already done this once. The result is this file right here. You can name yours something similar. Remember, Reach 5 is the section of the stream I was working on, and this is just reminding me that it's a digital elevation model so that when I see it,
Now that you've created that digital elevation model from the structure from motion data, we're going to take a look at what that can do for us. Ultimately, we're going to create 3 different renderings of the cross-section of the stream where you and your group gathered data. And we're going to see how these different techniques visualize or assess the stream differently. And ultimately, we'll find that the data we create from structure from motion is far more detailed than anything we can get from a publicly available source. For example, here's a publicly available source on elevation. This is a digital elevation model that I got from NOAA, the National Oceanic and Atmospheric Administration. And I put it up here just to take a look at what a raster, elevation raster is. When you zoom way in, you can start to see individual cells. These cells are about 2.5 feet on the side. So if I measure how far these are from one corner to the next, about 2.5 feet. Bear in mind, when we took measurements ourselves going across the stream, we took measurements every 1 foot. So at least on that cross section, our measurements theoretically are better than these. Our new raster, the one we just generated using structure from motion, is pretty small. It just sits right here. But look at the detail. It's pretty exquisite. Now, a lot of that detail is kind of false detail because we have limited information. You might remember the pictures I was working with were not all that great, and so there's some things that are wrong with it. But what we're going to do is, instead of looking at these as we are right now, we're going to insert these one at a time, and the workflow explains how this process works, as an elevation surface. So I'm going to go to Add Data and go down to Elevation Source Layer, and I'm going to find first that DEM. And you'll see the DEM, the one from NOAA, lives in the Lab3 data zip file. So you have this. I'm just going to indicate that I want to insert it as a surface layer, and when I do, I don't actually see it. It's sort of invisibly telling me what elevation is wherever it happens to be. And what I'm going to do is go to Analysis, Exploratory 3D Analysis, and generate an elevation profile using interactive placement here at My Reach, which is number 5. I'll click at the left side, go over to the right side, and double click, and I have an elevation profile of Reach 5. Now this is based on that LiDAR data, so it's a 2.5 foot resolution, meaning it's taking a measurement here, here, and again here, and so you're not getting terribly detailed information. But it's about the best available elevation data we can get for this level of detail. Now, once I have this, I'm going to insert this into my Lab3 deliverable. I can actually export the graph as a CSV table that I can open up in Excel and make a graph that looks just like the one or much like the one I generated from handmade data. Or I can export an image of this, or I could turn on the snip tool and just copy the graph itself and paste it into my layout. Now, for contrast, I'm going to show you what happens instead of using the DEM. I'm going to use the surface that we made as an elevation source. And when I use this Reach 5 DEM as an elevation source, I'm going to repeat the elevation profile, double click, watch how much more detail we get. Now again, some of that is false detail in the sense that what happens outside the channel is kind of unclear because all of the pictures of our reach were taken from inside the banks. The Group 5 didn't walk the bank, so we don't have a lot of detail about what happens outside, but I'd say this portion of the graph is probably much more accurate, much more textured, certainly, than what we can get from publicly available sources. And that's kind of the point. We can make better pictures, or better elevation depictions, models, from images at this sort of scale than we can expect to find from, say, the United States government or other agencies, at least for now. So when you want really fine-grained stuff, you can make it yourself. And that's sort of the lesson here.